Okay, I think I will have to stop the screen and restart it in a couple of minutes. Oh, wait a second, I think the sound got better. Ha! That's weird. Yeah, okay. Okay, I think we can manage like this. Okay. Sorry for all the trouble, guys and gals. Okay, I was hoping that I can use the screen capture, but I think it doesn't work. I think that was what gave me the choppy recording, but I don't know. So let's start from scratch, basically. I will simply work on the 386, which is kind of fine, I think. You have to deal with the clickety Model M keyboard here. So there were one question was by Matthias, what do you use to capture your 386? So I have an extremely cheap USB 3 very cheap USB 3 HDMI capture device. I think that was something like 50 euros on eBay. It looks pretty high quality and it captures all the weird formats that the PCs output, so that's pretty nice. For converting to HDMI, I use the open source scan converter, which is an open source project. It's not cheap, but I tested cheap variants and they would always choke on the old MS-DOS resolution. It's like 320 by 200 and stuff like that. So yeah, that's why I don't use anything cheap there anymore. And I think the OSSC is something like 120 to 150 euros. And they're coming out with a new revision this year. So you might want to hold off buying that if you are thinking about it. But I can say I've been using it for well over a year now, and it's almost perfect. Yeah, but maybe we can come back to the topic, talking a bit about coding. And while I was on mute and while the sound was bad, I was talking about how I got started with C programming, and maybe you guys have some questions or want to learn particularities about MS-DOS or C programming. And yeah, anyway, I was talking about how I got started. I got started back in 1991, I think, when we got our first 286. Never had a PC before or computer before. I knew they existed, and some friends at school had a C64 and similar stuff. But that was the first time I could use one every day. And I got started with BASIC, as many probably have back in the day. GW Basic first, then with MS-DOS 5 came QBasic, and probably everyone still remembers Gorillas. Actually, you can have a look if I have this installed. If I press the right... Yeah, QBasic is installed. That's good. Let's see if we have Gorillas. Okay, I'm too stupid to use this. Oh yes, Gorilla is here. And yeah, so the nice thing was you can look at the source code, and as a kid that was very nice. And it's name of player 1, yeah. It was very nice to play with this. View intro, play game. Or we just play the game. And it's basically a Scorched Earth variant with graphics in BASIC, written all in BASIC. And what do? You have to enter an angle and a velocity. And the gorillas throw bananas at each other, and you have to hit the other gorilla. And I was impressed as a kid. You could program games and you could actually look at the source code. So I started writing stuff in QBasic, and it has a very nice built-in. Can I break this? Yes, I can. Has a nice built-in online help. So I didn't really need a book at first, but yeah, BASIC is limited. I wanted to do nice graphics, animations. I wanted to do stuff that Sierra or LucasArts could, and there's a limit that you can do in, especially in QBasic or interpreted basics. So I tried to get started with C, but I was a little bit too stupid back then. Not enough English knowledge and not enough experience with programming. So yeah, I finally got a hold of PowerBasic, which is a basic compiler, because QuickBasic, Microsoft QuickBasic, wasn't available as a pirated copy, and buying that was too expensive. PowerBasic, on the other hand, was I think at first I had a pirated copy, and then there was a very cheap copy bundled with a book for something like 70 Deutschmarks. And that's something I could afford as a teenager. So I got started with PowerBasic and coded stuff there, wrote a little program. You can still use QBasic shipped with Windows 90X. Yeah, 90, 95, 98. It's mostly the same. That's true. Except it cannot compile. Exactly. QBasic can't compile. QBasic is an interpreter, and I wanted to make exe files. I wanted to sell them as shareware and stuff. Earn some money as a kid. So I wrote with a friend of mine at school. I wrote a little program with cheats, hints, and solutions for games. We put in something like 40 games in there that we played ourselves. Of course, all pirated copies, but nobody knew that. And we wrote down our solutions and cheats that we found and collected from other media like magazines. And then we put in something like 10 games in there, and we said, if you pay us 10 Deutschmarks, you get 40 games and updates and stuff like that. And actually, we sold a bunch of that. I think we got something like 100 Deutschmarks per month from registration, so around 10 registrations per month. And that got me started with all the coding. And yeah, that was nice. But PowerBasic also had its limitations. I started to do more graphic stuff. And yes, Matthias, exactly, you could use assembler libraries or inline assembler. And I even did, you probably saw my VGA copper bar video in Toba C, which is, we can open that up. The question is, where did I put it? Did I put it here as well? Maybe under Let's Code? No, probably didn't put it here. Or maybe I did. Copper here. So let's see if I can run it. Yeah, it compiles. And it does something, yes. Okay, you can see something. So these copper bars, which is heavy VGA I/O port manipulation. And you have to be very, very fast with that, because you have to do VGA manipulation on every scan line. And I even did that in PowerBasic. I was barely able to do that. It was just fast enough. But doing games was almost out of reach with PowerBasic. Makiso says, copper bar, wasn't that Amiga stuff? Yes, originally it was Amiga stuff, but each system had their own variant, as Matthias rightly says. So, yeah. Then I got back to C, actually, and because there was a lot of source code available on share disk and stuff like that, which were actually C. And I thought, well, maybe I can get my head around that, because all the demo coders and everyone is using C or assembler, so I should probably get started on that. And I think it was around 1995, 94, maybe 94, when I seriously got started with coding in C. First Toba C, later DJ, GPP. Matthias is a C and assembler coder. Okay, maybe. I think he's more a hardware guy and a baker, but maybe he also does C and assembler. Anyway, I got started with Toba C, and I did a little game that I lost, and that is, I think, nowhere to be found on the internet, with a friend of mine. He did actually the major work because he had more experience. He coded the graphics routines, I think even Mode X and stuff. I added some lame sound routines and painted the graphics because I think I was better at that. And again, we sold it as a shareware game. It was a complete ripoff of a C64 game called Krillian. And I think there are a dozen variants out there still of that game. And it sold reasonably well. Again, we got something like 10 to 20 registrations every month for 1 or 2 years, and that helped me buy more hardware stuff. And it was a nice experience. And that was basically my experience in school doing stuff like that. But I never put down C again, or C++ for that matter. Since then I've been coding C and C++. Shortly after that I discovered Linux, and with Linux you basically have to do C or C++ if you want to code, especially back in the day when there wasn't stuff like Java around. Java came out probably around the time as well, but was not widespread and not yet ported to Linux. Yeah, so here we are, and my dream is still to do some game coding for MS-DOS, because I actually like that, because the system is powerful but still limited, so that you have to be creative in what you can do and how you do it. The VGA card, the Sound Blaster card can do quite a lot of stuff, but you have to think very hard how to work around its limitations. And using the 386 and protected mode gives you a lot of advantages, more RAM, no segmentation and stuff like that. But I think for now I want to stay with the real mode, because it has other limitations, and it will run on 286s and maybe even slower stuff. Yeah, so what you have to keep in mind when doing stuff like that is what kind of tools do you want to use, what language standard is supported, because with C things had been evolving very slowly for a long time. So C was invented in the late 60s at the AT&T laboratories in conjunction with Unix, actually. Unix and C existed more or less at the same time. Unix came a bit earlier, but C was basically developed to make Unix portable. So we had C for already 20 years or 25 years before I got started doing that. And Makiso has a question. Talking about assembler, how far near to SM can you get with C in your opinion? 3 times slower or 10 times, or sometimes only fractions, without inline assembly, of course. Okay, what he's talking about here is performance. So if I write a program like this and have some loops and statements, how much slower is it actually compared to handcrafted code written in assembler? And people who don't know assembler, it's machine code, basically. And you can do inline assembler by writing stuff like this, opening some curly braces and writing SM. And then you can write assembler opcodes, which is something like this. Morph dx AX or something, which means move the value that is in the AX register to the DX register. This is similar to what you would do, let's say, if you had register union and would say rex dx equals rex AX. So what the compiler does is actually read the C code and produce assembler opcodes, more or less. So at least modern compilers will do it sort of like that, probably not with the intermediate assembler form, but writing directly binary opcodes. But sometimes you can still have compilers which do the assembler in between thing. And of course handcrafted stuff can be optimized until it's as fast as the machine gets. And with C It depends. Many things will be very efficient because C is a very simple language, and modern compilers will be probably even better than the average handcrafting coder. And Mr. Applegat is joining. Good evening, Mr. Applegat. So I would say with Turbo C there is probably not a factor of 2. I think it's less than a factor of 2 that it's slower, and in many cases it will be as fast as you can get with 8086 and 8286 assembler. But a coder will usually know more about the machine and how it behaves, and there are people like MobyGamer, or what's this other handle, he did the 88 miles per hour demo, and he basically even counts clock cycles of each instruction and optimizes that. Hi Thomas. Thomas Kemkes joined. Very good evening to you as well. So I would say for most normal coders and people, C will be fine under MS-DOS and on these old machines. But going some more low-level stuff, tight loops and stuff like that, might benefit from even doing assembler. And of course you can write C code that is very inefficient, and it won't be helped if you write inefficient code in assembler as well. Boyan Vidolov, good evening. Welcome to the chat. And for all those joining now, we had 10 minutes of audio problems, but we finally got started. And if you have any questions, please type them in the chat. I have to do the stuff now on the real 386, so you're watching a real old machine here. Because I think I might have had audio problems due to screen capture being too slow. But this here is really fast. Yeah. Jackson, hello Jackson. Jackson says, it's almost impossible to write with today's compiler faster code than they compile. Yeah, as I said, the optimizers are nowadays very, very, very good. And the CPUs have become so complex, they have so many extensions and stuff, and the multi-threaded code. Today it's hardly worthwhile to write any assembler on like a Core i7 or I don't know. And especially with the complexity of the programs. But we are writing simple stuff here, so doing either assembler or C is actually fine. And there were a lot of games back in the MS-DOS days which were written completely in assembler, and still are. A bunch of examples I can show you. One of the games that is written completely in assembler is Elite 2 Frontier. So this is, you probably know Elite Dangerous, and some of you also know the original Elite game. And this one here, let's see, we might even get music. But I probably have to tune down the volume, I don't know. But this game here, with a lot of 3D graphics, that was only possible by doing it in assembler. And David Braben, I think, wrote at least, he either wrote the Amiga version or the PC version, I don't know. Someone else ported it, but I'm not sure on which platform it originated. And this was back in 1993 when it came out. And this looks crappy, but it was back then quite spectacular that you could render a whole galaxy with planets and stuff. Yeah, so this was definitely a game that was written in assembler. Same goes for, I think, the Pinball Fantasies and Pinball Dreams game. And yeah, and of course, modern homebrew game would be Planet X3. It's also written completely in assembler. And yeah, you probably have heard of it if you know the 8-bit guy. It's a little homebrew game from a year ago or two, and yeah, it's a sort of like a real-time strategy game And it's quite impressive that people come out with homebrew games nowadays. And I like that. That's something I would want to do if I get a little bit more time for doing that. Right now, I'm happy with the Let's Code videos. But eventually, this is supposed to become a game anyway, that we're doing here, but a very simple example game only. The 8-bit guy, Makiso, yes, he did the Planet X3. Okay, Polar Boys is asking, is this PC shell? No, what you're seeing here is my favorite Norton Commander clone of all times. It's called the DOS controller. It's tiny. It's tiny. I can show you. It's also written in assembler, actually. It's just one COM file, the size 49 kilobytes. And it's very powerful still. It lacks a lot of features of the original Norton Commander or the Volkov Commander or Total Commander. Can't open archives and stuff like that. But I like it pretty much. Yeah, Volkov Commander is very popular. Total Commander is pretty popular for Windows. And it's similar to that, but I like this one here. It's freeware, it's tiny, it consumes almost no memory, and it's fast. It has some drawbacks. It doesn't support CD-ROM drives and network drives. Yeah, DC stands for DOS controller. You can find it if you search for it, and it's all in Danish, the documentation, because it was from Søren Krach is his name, guy obviously from Denmark. Oh yeah, here's the here's the English documentation. It's an optimized version of the Norton Commander in that it's faster and uses less RAM. And it can actually load pretty large files. You can actually load big files like, for example, let's take the Frontier executable, which is 100 kilobytes, and you can simply load it and take a look at the bytes there. And Norton Commander couldn't do that. Norton Commander could only open stuff less than 64 kilobytes because it could only load one segment. So yeah, I like this nice little tool. But you can pick whatever you like. Yeah, let's go back into Toba C. Maybe there are more questions. Jackson says, I saw the assembler the 8-bit guy used. The compiler was so simple and awful. Yeah, he used not a professional assembler for coding Planet X3. I think he used, I forgot the name, but it was something for teaching assembler actually. And yeah, he was actually supposed to switch to something like NASM, what is it called, NetWide assembler, NASM, or Toba assembler, or Microsoft assembler, or whatever. They are much more powerful, they offer macros and stuff, and I don't know. But he actually made a whole game with just the learning assembler, and he used, I think, the something like Notepad or macOS text edit for coding the whole game, so you don't need big tools to write good stuff. If the coder is good and yeah, the project is not too big, then you can use very simple tools. And there are definitely better assemblers available than that, but if it works, then it can't be that stupid. Okay, does anyone have any other questions? I'm just rambling on a bit here. Is anyone curious how some certain aspects work, syntax or particularities of MS-DOS versus other platforms? Because let's face it, coding for MS-DOS is different, especially for real mode DOS. If you go to the online help. There's another question here. Acture Prof says, hey, where can I download your Toba C with examples? Yeah, that's I can link to that. You can just go to my YouTube channel and follow the Let's Code MS-DOS videos. Every The very first one actually has download links for, the very first episode has download links for Toba C, which is freeware by now. And every episode has a link to GitHub where I put my code. So you can follow with the code, and in the very first episode it tells you where to download stuff. Marquiso asks, Toba C, what version? Let's check that. That should be actually version 2.01, but I think we only see that when I start it up. Does it say? No, it doesn't. And it doesn't have an about screen, but I'm sure it's 2.01. This is the version that I prefer. No, it doesn't say anything. Yeah. Okay, what I wanted to say was C is actually standardized, so there was first an ANSI version. ANSI is the American Standards Committee. Another good question is coming up here. But let me first talk about this. So ANSI C was the first standardized version. Then there came ISO C, but that was only in the 90s. And ANSI and ISO C define a bunch of header files which you can include, which is basically the library. And what you can see here is mostly the standard library. Everything called STD is standard library. Something like math.h is standard library, and string.h is standard library, but some other stuff like BIOS, ConIO, DOS, that's completely proprietary to DOS programming, and particularly Toba C. So Microsoft had a bunch of these as well, but you couldn't have necessarily the same functions in there or the same names. So you have to be careful if you want to write portable code. Then you will have some work to be done. If you want to port one of the examples to Linux, that will be very tough because I'm using a lot of DOS particular functions. Okay, so another question here is, what are the differences between Toba C and Borland C? I think Borland at some point stopped the Toba series, or Toba was the cheaper version. I think there was things like Toba C and Toba Pascal, and later Borland C and Borland Pascal. But I'm not even sure how many versions of Borland C there actually were. I do remember Borland C++, but I remember it this way, that the Borland series was the more professional version with maybe more libraries or more manuals and stuff like that. Jackson asks, do you know why everybody says programming for CGA is so terrible? No, I don't. Apart from the fact that the CGA was the first graphics card together with the MDA card, so the very first PC graphics cards, it was of course very limited. And the very first IBM versions also had a lot of problems, like when you wrote to the video memory, this would produce snow on the screen. So you should only write to the video memory in the vertical retrace and stuff like that. So I think because of its limitations, it was probably not that cool to program for. Boyan Vidolov says, I think that you need to write to 2 registers for even and odd scan lines. I don't know about that. That's probably concerning the CGA stuff. So I actually never did CGA programming because I don't have a CGA card actually. I do have an EGA card, but I don't have any monitor to hook it up to. My LCD screen has a VGA input, and I do have the OSSC. And I think in theory I could hook up a CGA card to the OSSC because it has RGB inputs. But it doesn't have any intensity input, and the CGA uses RGB plus an intensity pin, and I would need to solder something to convert that to pure RGB. Neonum says, this H files horrified me back then in the early 90s when I was a first grade student and just started studying C. It looked so bulky, compiled slowly, created huge X's. all in comparison with Toba Pascal. Yeah, and that's still true, actually. Even C++ still has this horrible notion of header files. One huge problem of C and C++ is that it doesn't have a proper module concept. It knows about compilation units, and it has the C preprocessor which handles the header files, but it's actually a huge hack. Other languages like Java or Turbo Pascal or similar things, they do have a module concept, and that's where they are so much stronger than C. The next C++ standard will actually introduce modules, but for the time being, and especially if you're coding for MS-DOS, then you will have to deal with the header files. And they are, as I said, more or less a hack, because they are just included verbatim. They are copy and pasted to where the include statement is. So if I write a hello world program, I will have to include the file called standard.io.h, which contains the definition for printf. And by doing this, the C preprocessor will actually copy the whole content of the standard.io file here into my file called noname.c. And that's pretty lame. So, and I can, in theory, could even write a second time include standard.io.h, and it would copy it a second time if you don't write some special include guards into the header file, which everybody does, but which is totally useless because that could have been done by the compiler. So that's, in my opinion, a very big weak point in the part of C. But it's probably due to when it got started back in the 60s that there was no such notion of modules in programming languages. Probably came later, probably with some languages like Modular and Modular 2 and 3. If I should guess, I don't know. Next question. As we're here with headers, includes especially DOS-H and other systems with C, Amiga mostly. How do I get documentation of this, or how do you do this? Yeah, with a little bit of luck. So, for example, with Toba C, you can actually download a PDF version of its manual. For Toba C 2.01, you can actually download a PDF. I think I linked that in one of my Let's Code videos as well. And there is a lot of documentation then about those specific headers. But other than that, at least Turbo C also has documentation inside of the online help. So I can go to dos.h, and of course it doesn't say everything, but you can, for example, go to disable and it says disables interrupts. Prototype in dos.h disables all hardware interrupts except non-maskable interrupts. See also enable, which makes sense, enables hardware interrupts. So that's what you can look up. But it's not perfect, and it's actually pretty limited, because you can see it's very short and terse, and some things will be a bit shorter than you probably want. Get CWD, gets current working directory, and so on and so on. But yeah, it leaves a lot to the imagination. And for the Amiga, I don't know. Probably there's documentation for the Amiga SDK or something like that. Yeah. Next question by Jackson. EGA or CGA, not sure which was awful. Yeah, they probably both were awful and great. So the CGA was actually better than a lot of people remember. There are a couple of videos on that, not by me, because the CGA card can actually be coaxed into displaying more colors than usually people associate with it. It used to be only 4 colors, but if you lived in the US and had a composite monitor or a TV simply, it could actually produce so-called artifact colors by displaying stripes on the screen which were misinterpreted by the TV as more colors, which is funny. But it was used by quite a bunch of games. Early Lucasfilm games and Sierra games, for example, used that. And so you could actually produce 16 colors on screen, and with modern tricks you can even produce more, but that wasn't usually available back in the day because people didn't know that you could do that. And EGA wasn't actually that bad. It supported 16 colors out of 64. So there was a whole palette of 64 colors, and you could choose freely 16 colors from that. But to remain compatible with CGA and its RGB plus intensity pin, most games limited themselves to the CGA 16 base colors, which are the very bright colors that you remember from DOS, which is basically what we're seeing now on the text screen. Those are the same colors. But there are a few high-resolution games that support the advanced EGA palette. For example, all the Legend text adventure games with graphics, they support that. And a bunch of other shareware games mostly support that. And you could actually produce pretty nice pictures in that high-res mode with 64 colors. But yeah, it definitely wasn't that widely available. Planet X3 has a composite mode. That's correct. That's one of the things that the 8-bit guy targeted, because he is a big fan of the Tandy machines, which supported their own version of a sort of CGA standard. But he got basically the CGA composite for free by doing the Tandy mode. Jackson says, one word, C and strings. Yeah, shall I talk about C and strings and pointers in general? Because that's usually what people are afraid of or confuse. And Polar Boy says, I wish I could do palette switching in EJ 320 by 200 by 60 mode. I think you can, but you have to program the mode yourself. I think the BIOS mode doesn't allow that. Yeah. Marquiso says, but EGA was kind of slow. Never seen anything real fast on EGA 60-70 frames per second platformer. Commander Keen was 30 frames per second, I guess. Again, it depends. There are a few demos from the demo scene which actually use EGA modes on the VGA card nevertheless. So they use the VGA palette registers to get even more colors, but use EGA style bit planes to get very fast polygon rendering. So EGA was not necessarily slow, but there were few games which actually really pushed it to its limits. So I think it was a card that came very late, somewhere in 1984 or 85 with the AT, and was superseded already 3 years later by the VGA in 1987. So I think it never stood a chance actually, and the VGA was so much better. And yeah, C and strings. Let's come back to C and strings. So is there anything that you want to know about that? Let's already write a main function in preparation for that. So C and strings. Pascal actually does strings better, probably, talking about DOS. In C, strings are pointers to character, which is already confusing for a lot of people. And you can write them down. Okay, I have to rename this. Let's call it hello. And overwrite the hello that I have there. So this is what a string looks like in C. And actually, in modern C, it should look like this, because this here is actually a string literal, and string literals are constant. So what does it mean? A const variable can actually not be changed. It's immutable. So I should not be allowed to change any letter in there by manipulating it directly. And yeah, C, in comparison to Toba Pascal, actually adds an invisible 0 byte at the end, which you would write like this, to notify that the string stops there, which has advantages and disadvantages. C string manipulation make me angry, says Jackson. Yes, kind of. So modern languages will abstract from all this weirdness, but in C you have to deal with it. And the rules are not that complicated, but it sometimes is inconvenient and it can lead to errors and memory corruption and stuff like that. So can't be more difficult than in assembler. Assembler does it basically the same if you want to. I mean, the assembler doesn't know anything about strings and stuff like that per se. You can implement them the Pascal way or the Toba way. So in C, basically you can have strings of infinite lengths, or in DOS probably the length of one segment, or with more magic even more segments. But in Toba you can only have strings the length of, I think, 255 bytes, because the first byte will be the length of the string. So for root 42 there will be a byte saying I'm 6, and the tools will read that and they will know, okay, I have to read 6 bytes now. So you are very limited in the length of the strings, but determining the length of a string is very fast, because you just have to read 1 byte. With C you have to loop through the whole string until you find the 0 byte at the end. So that's a bit weird. And C is so low level, so low level, that you can't do the following. So you can't go here and, I mean you can, but it will lead to weird effects. You can write something like character S2, let's call it like this, equals S, and then I can do the following. I can write this here, and I will explain it as I go. This will print out both strings with a dash in between. %s is the placeholder for a string, so I will print a string s and then string s2 and add a new line, and this will probably work. And it says root 42 and root 42. That's nice. However, when I try to manipulate one of the strings and I'm saying I want to replace the first letter by the letter T, and I compile that, actually both strings get changed. So this assignment that we did there isn't actually a string assignment as you would be expecting from Toba, Pascal, or Java, or any sane language. Or actually not Java. Java does it even weirder. But it's actually just an assignment of the pointers, because strings are pointers in C, as almost everything. There's a question in there. Marquiso says, okay, here character is the type, like integer, float. I'd assume string as type. And what's star as? Okay, that's the basics. So C doesn't have a string type per se. C only knows very few types. It knows int for integers, float for floats, and double for double precision floats. It knows about characters, and everything else is built from pointers of those, and maybe from structs and similar things. So the full type of this string here is const character star, which means this is a constant character pointer. And character pointers are strings. That's what C understands when we say strings, but it's still a pointer. So the variable itself isn't this string here on the right side, but it's a pointer to that. So basically the memory location. And by doing the assignment here, we just copy the memory location and not the string itself to that thing. What we should instead do is include a library called string. Come on. String.h. And there's a function for that. It's called string copy. And string copy works, I think, like this. We can ask the online help. copies string source to dest. So first comes the destination string and then the source string. Let's see the questions. I'm a beginner in C, but it means an array. Strings are a construct that are in fact char arrays. Yeah. Pointers and arrays are the same thing in C. That's the most basic lesson that you can take. Strings, arrays, and pointers are basically the same thing. A pointer to the first character in the string in memory, Marquis. So yes, basically. However, this program will probably work under C, under DOS. Under Linux and macOS, it will hopefully segfault because actually this is still wrong, because we need to give this thing some memory. So what we actually have to do is to allocate memory before we can actually copy something there, and that's the malloc function. And the malloc function is contained in which header? Who knows which header? We can actually hit Control F1 to hear that. It's, for example, in alloc or standardlib.h, and it takes a size and returns a pointer. So yeah, let's just simply include the standardlib, and we need to tell it the size, and the size is something that we can ask with the function string length. String length gets the length of a certain string, and the string that we want to know is s. So this will give us 6 bytes, but there's one more byte, the 0 byte at the end for marking the string end. So we have to do it like this. We allocate some memory of size 6 plus 1, and then we copy that. And if we run this, we can take a look, and now we get root 42 and toot 42. Now we finally managed to get a copy of that croding string. Yes, and be able to change something like this. And in languages like Python or Java, this would be so much less code, or yeah, it's definitely a hassle because it's so low level. So some people say that C is just a fancy assembler. Let's see the questions in the chat. String begins at memory address a hex, for example, so star s contains the a hex address. Yes, exactly. We can actually show that. We can put in here percent. Now I have to look up the codes. I think format hexadecimal %x. Let's try %x for this and put S2 here. See if this works. Okay. Gives a weird address. So it says address 8. Maybe that's true. But that's basically the address. I would have hoped that I get something like a real segment address, but I probably need to do some more magic for that. Pointer. Look at this. %p is possible with, but this is a Toba C, and this won't work in Linux, I think. Yeah, now we have the address actually, and it was address 8, so we only got the segment, the offset. The first 4 characters here, or the first 2 bytes, are the segment in the PC memory, and the second 2 bytes are the offset in that segment. And we got the 8th byte as the first thing, because probably the other string takes up the first 7 bytes. Make sense? Yeah, so this is string handling in DOS and in C. And yeah, you can try to get around using pointers and stuff, but you will be limited, severely limited in C, if you don't know your way around pointers and those types. And there's also, here we don't see a big difference, but especially on other platforms you will see huge differences and in where the variables are actually allocated. So when doing something like this, the first string, that's actually put on the so-called stack usually, which is a limited area in memory, which is used for storing the call stack. For example, if you go into a subroutine, all the pointers and parameters will be put there, and it's very limited. You can only go so far into the stack until it overflows and your program crashes. However, the malloc function will return memory from the so-called heap. Under DOS it's even different. There's a standard heap and there might be a far heap, which is in a different segment. So there's something else to note about that. And yeah, but basically if you have large objects, you should always put them on the heap by using malloc. And if you do malloc, there's the next problem with C. You actually have to release the memory, because Java and Python, those fancy languages, they have garbage collection, stuff like that. But C doesn't have that. And if your program were to continue, you would leak memory. That is, the memory would never be accessed again, but was still taken. And your memory would shrink, and at some point your PC or your program will crash. So here we don't have to do that, because we finish the program and then everything gets released anyway. But if you don't finish the program, then you have to free the memory. So malloc always has to have an opposing free, or you have memory leaks. Let's see the chat. String length is determined at runtime. Yes, it is. It always goes through the string pointer until it finds a 0 byte. That's the implementation of string length. Because it can't know. It can be anything in there in the string or the memory it points to. It can even change if you have multi-threaded programs and weird stuff like that. But why do you use string length and not string length star s and string copy? Okay. So when do you need the star and when do you not need the star? That comes down to the definition of the thing here. So at least in C++ it would. In C it's actually simpler, because string length actually takes a pointer to character, and just writing s gives us a pointer to character. If you were to write star s, this would actually take away the pointer, because the star operator in C takes the address that is stored in this pointer and actually gives you the content, and that's of a different type. If s is a const pointer to character, or a pointer to const character, then star s is actually a constant character and only one character. So if I try to compile this, it will give me at least a warning here. Modern C would give me an error. It says non-portable pointer conversion, because I actually get a character out of this, and I'm trying to force it into stringlen, which takes a const character pointer. So that gives a warning, and that will not work. So the star is only needed if you need the content. Okay, what does the chat say? Not only fancy languages have garbage collection, BASIC and Pascal also have them, kind of. Yes and no, but still with Pascal... Oh, it's Toba Pascal is too long ago. I really forgot how they deal with that, but I think you can also allocate and free stuff on the heap, if I remember correctly. But you don't have to deal with the pointers in such an excessive manner as you have to do in C. Marquiso says, so S is the content and star S is the address. Yeah, no, the other way around. Exactly the other way around. So S is the address and star S is the content. Except if you're talking about the type, then character star is the type of the pointer and character is the type of the content. And you can do even weirder stuff. You can do weird stuff like this. To pass arguments from the command line into a program, we can write something like this. Every C program supports for its main function, and there has to be a main function if it's a program, that's in the standard. You can't call it anything else, at least not trivially. It supports two parameters. The first one is the so-called argument count, which is an integer which tells you how many command line parameters did you get. There's always at least one. Argument count is always 1, and the first argument is always the program name. And then the second one will be the first parameter, and so on. And what do we have here? Here we have a character pointer pointer. So this is a pointer to a pointer. Or, because pointers and arrays are the same thing, you have an array of characters. Or, in other words, you have an array of strings. Sounds very weird. Other languages would write it much simpler, probably. But this is the way that C does it. And it's until today. If you write a C++ program in the most modern C++ dialect, the main function will still look like this if you want to have command line arguments. And how do you access stuff like that? Let's see. Let's do another printf here. So you can write something like this. Our program is called %s, and I can either do star argument value, which gives me the first entry, or I can try to access the second value by doing this. So the first value would be +0. I can add increments onto the pointer, which gives me always the next value. This will be the second value, but you must not do this if there isn't a second value, or you get a segmentation fault in Linux or macOS, and you get weird stuff under DOS, because DOS doesn't check anything. Or the other notation, because pointers are arrays, is actually to use the square brackets. And we can just write this. This looks more natural to users of other languages. So we can run this and we should get the program name. And there you go. The program is called C Turbo TC Hello Exe. And that was in the first entry of the argument vector. Let's check the chat. Does Toba C handle far pointers automatically? No, it doesn't. You actually have to write far. If you look at my other videos, I actually handle that there. And if you want to, for example, have a string on the heap, on the far heap, you write something like character far s3, and this far thingy is actually also not ANSI C. This is totally DOS specific, won't work on other platforms. And we have to use something called far malloc and do something like string length of s +1 here, and then we can actually allocate something on the far heap. So it's not handled automatically. You have to deal with it yourself. Jackson says, I never understood types like x and x and witchcraft. Okay, I don't know what you're talking about here. This looks more like C++. So there are type forwarding references in C++, which I won't deal with today because that's a whole different topic. We can do another Let's Code about C++, but that will have some some very weird stuff in there as well. So yeah. But anyway, I hope this brings across the point how to do things like that. If you want to actually look at the other command line parameters, you would have to write a loop over argument count argc and only process those vector elements that are actually defined. And this is something, again, which is a bit weak in C and C++. The standard vectors don't check if you access something which is out of bounds. You can enable checks in Toba Pascal, and there are other languages that do those checks, but C doesn't, which on one hand is fine, because even if you handle that in other languages, they will most certainly throw an exception that you will have to deal with, and it hints at something being very wrong with the program if you access something outside of the bounds of an array. But in C, it's especially under DOS, it leads to very weird behavior if you access something outside of the bounds of an array, because nobody tells you that it's happening, and the program will continue to run, but probably will do weird stuff, output garbage on the screen, lock up the machine after 5 minutes, and similar things. Polar Boys IK Woodstuff says Jackson like in and variable name. Yeah, here we're talking about references, call by value and call by reference. This is not supported in C. So in C++, you could have something like a function which we call f, and we pass something in like an integer, and we write something like this. This would be a reference in C++. That means we don't actually make a copy of the value I, but it gets passed sort of like a pointer, but the compiler can skip the entire pointer part. And the object is not copied, which is especially important if you have like huge classes with lots of data attached. In C, you will always have to do it like this. You will have to pass a pointer, and then if you want to do something with this, for example, if I want to return the value in there, I will have to dereference it and do something like, for example, I want to add 2 and return that. This is the way you would have to do it in C, actually. Horst Thorstensen says, have you ever done programming with memory extenders like DOS4GW? Is it even more complicated than far pointers? Actually, it is so much simpler, but it has other problems. And yes, I did. I used not DOS4GW, which is a DOS extender, and for people who don't know what that is, MS-DOS and its relatives run in the so-called real mode of the x86 CPUs, which is a mode compatible to the very first AT86 processor, and it allows you to access exactly 1 megabyte of RAM, not more, not less, and that's it. Even if you're running this on a 486 or a Pentium or even newer, this huge machine is crippled to the power of the original IBM PC, basically. And a DOS extender circumvents that by actually switching the CPU, usually a 386 or higher, but it's actually also supported on the 286, into a special mode called protected mode, which gives you access to all the memory, up to 4 gigabytes on machines until the Pentium, and then later machines. There's even some weird new DOS extenders which support 64 bits, so even more than 4 gigabytes of memory. Okay, long story short, I was using DJGPP, which is the DOS port of the GNU GCC compiler. Back in the mid-90s, I think I started with it in 1994, sort of. And it's actually easier to code with than with the far pointers and stuff, because you get a flat memory model. There's no segments anymore, no near and far. You can just simply call malloc and do stuff. However, you still can access the real mode part, the lower 1 megabyte, with special pointers. For example, if you want to output something to the VGA card, you will have to construct a special pointer, which points to the A000 hex address of the VGA memory. And it gets even more complicated. You might need some BIOS or DOS routines to access files, to do some other stuff, and those cannot run in protected mode. The DOS extender will allow you to call those things, but when you call them and you have to pass a pointer to them, because, for example, you want to write a file, you have to give DOS the file buffer somewhere in memory with the data, you actually have to make sure that you allocated some memory in the lower 1 megabyte, because otherwise DOS can't see it. DOS will run in real mode, and the DOS extender will switch back to real mode for you by doing, when you do the DOS interrupt call, and pass the pointer to your data to DOS, and then DOS will write the file, for example. But you can't just take any pointer, so there are special functions in the DOS extender to give you memory in the lower 1 megabyte or 640 kilobytes. So in one way, the game logic and everything else is usually easier to program for, because you have tons of memory. You can just do flat pointers and flat stuff everywhere, just like you do in Linux or macOS. But on the other hand, if you have to talk to DOS or the BIOS, it gets complicated. Yeah. So that's why I'm currently sticking with this whole Toba C thing. And also, as I said, DJGPP and, for example, Wacom C with the DOS 4GW will only run on a 386 or higher. There are DOS extenders for 286, but the 286 protected mode is very slow if you want to switch back to real mode. Because Intel, in its very, very, very big glory, thought nobody ever wants to quit protected mode. We invented the 286 with the protected mode and more memory, so IBM and Microsoft can write new operating systems which take advantage of this huge memory. And when they do that, they never want to go back to real mode with only 1 megabyte of RAM. Turns out people wanted to continue to use the DOS programs. So yeah, we do want to go back to real mode all the time. And that was a huge problem. That was why there are very few programs which support the 286 protected mode. And it only took off after the 386 was introduced, where Intel learned that, and they actually introduced the virtual AT86 mode, which can emulate the real mode in protected mode, actually. And that made everything much easier. And people later were very creative, and they found a way to kick the 286 back out of protected mode, but it's really a weird way to do that, because they are basically resetting the CPU, but in a way that the computer doesn't reboot, but only the state of the CPU is resetted, and a hidden opcode is used to actually reinstall all the register values that were there before. So it's a very, very clever and hacky way to do that, but it takes a lot of CPU cycles, so if you have to call this a lot, then your program will be very slow. Okay, so I think this is already quite a lot of information. I can stick on for like 15 more minutes before I will have to end the stream. So feel free to post some more questions. I'm very glad to talk about this here. So in the upcoming videos, I will definitely talk even more about graphic stuff. The last things were the smooth scrolling, and I want to enhance the Mode X graphics routines, because at the moment they are very slow. We will talk about how to do faster bitmap copies in the Mode X, and then actually put together that little game that I was hoping to do. And we will talk a bit more about scrolling and how to do that, not only panning around like I did in the last video where we just have something scrolling around, but to actually use that to animate a screen usefully. And yeah, so there's a lot of topics still to be covered. But again, if you have some special interests, feel free to leave a comment or write to me. And if time permits, I can definitely do an episode about all kinds of topics. Yeah. Okay. So, got quiet in the chat. Yeah, I think. Yeah. At the moment, I'm out of topics myself. I mean, I can talk about this probably for hours more, but I'm not sure what's interesting to you. And C and DOS in particular is really a rabbit hole. So there's a lot of stuff, and a lot of stuff that I don't know. There are definitely people who are much more talented even, but I think I've been doing this for such a long time that I know at least quite a bunch of stuff. Yeah. So here it's now 5 minutes to 10, so if there aren't any questions anymore, maybe we'll call it a day. For next time, I already know that I have to double check my sound test. And I will experiment, because I would love to be able to actually stream my Mac desktop, because I can show a browser and stuff like that, but for some reason I didn't want to do that today. I mean, it's nice to work on the 386, but if we want to look at some online documentation or something, that's not possible then. So, any more wishes? Anything to show? Any questions? Be it programming or gaming or DOS related. Thanks for answering all the questions, says Horst. Yes, you're welcome. For next time, I'd be interested in how you know how to init the graphics mode, etc. What steps it has to take. Yeah, of course. We can even talk about that very quickly now. There are multiple books and documentations about that. So I think IBM documented a lot themselves, but there are online documentations. And basically you can look up all the BIOS function calls and all the DOS function calls. I link to that in my Let's Code videos as well. There's one great website which I at the moment can't recall. Probably won't find in the heat of the moment. But I can tell you that I linked to it in my very first videos concerning keyboard and VGA. There are all the I/O ports described, all the DOS interrupts and BIOS interrupts. And if you go to my Let's Code videos, which... let's take the VGA example program. Basically what they will describe is the BIOS interrupts. The PC is actually, or DOS is programmed by using a special API which is triggered by calling interrupt functions, which is not like hardware interrupts but actually software interrupts. It's triggered by the interrupt opcode on the x86 and you pass it a value. For example, hexadecimal 10 is the video interrupt and you can set video modes with this. And you pass it a parameter in one register which says which function to call. Function 0 is set video mode. And then you pass it in another register which kind of video mode. For example, 13 hex is the VGA 256 color mode. And then you can tweak it with I/O ports, very low-level hardware stuff, which is what I deal with in the Let's Code videos. And there are a lot of websites concerning that. I do have still one very old book in German. It's called PC Intern from Databecker. It's a very, very, very heavy book and it describes all that stuff. But there are English versions of similar books. And there's, of course, the very great Graphics Black Book by Michael Abresh, which you can download for free by now. And it describes also how to enable all the graphics modes and stuff. More questions. If all your functions end up having one letter for a name, I think you're gonna lose some people along the way. Yeah, of course. In the Hello program, that was just to show what the stuff looks like in general. If I were to code, if you look at my other Let's Code videos, I use proper names. And it's just, for live typing, it's faster if I type only 1 or 2 letters, because otherwise I'm just clicking away on the keyboard. But yeah, that's right. A short story of your computer. What was your first own computer and first computer you ever used? I mentioned that at the beginning, but I can repeat it very gladly. The first computer I ever used was, I think, my cousin's computer, which was a C64, and we played Saxon on it. And I was very impressed as a kid, and we played summer games. I was 6 years old by then or something, was the mid-1980s. And the very first computer we owned was, or I had access to all the time, was a 286 back in 1991 with 1 megabyte of RAM, got upgraded to 2 megabytes of RAM to run Windows 3.0 reasonably well. And had a 30 megabyte hard disk, and I enraged everyone when I installed Monkey Island 2, which took 9 megabytes, and the hard disk was suddenly full. That's my very short first computer story, and later we got a 486 SX, and then I took that and upgraded it all the time in the 90s and early 2000s. Another question? Okay, if you write in your description, then it'd be fine for then, maybe. Yeah. Got PC Intern 3.0 this week. Yeah, that's good. I have the 4.0 revision, but yeah, that's good. Please put all links or help you get in mind in your descriptions. Yeah, I will probably update the video description with a bunch of helpful links. I just have to look it up in the old videos. So the description of this video will be updated, and you can check in half an hour or tomorrow, and it will probably show that. Yeah, I think it's 10 o'clock now. That should be a good endpoint to our video. If there's interest, I can do something like this again. I will probably do a lot of proper videos, of course, but I was hoping that because I get often quite a bunch of questions that people come in the chat and yeah, just ask stuff, and we can do things that I never thought about, or talk a little bit about DOS stuff and general things. So thank you very much. Please make sure that you subscribe to the channel, because we are very, very near the 1000 mark, where we can enable extra chat features and stuff. I can enable monetization, which will probably give me like 50 cents a month, but I don't care. And a lot of other things that they gatekeep for people who have less than 1000 subscribers. So that's it for today, and I hope to see you soon.